Welcome to The Explainer. Today, we're going to talk about the logic of maybe. It sounds simple, right? But teaching our computers how to handle uncertainty, well, that's changing pretty much everything.
All right, let's just jump right in with an example. You see a review like this all the time, right? This product is hilariously bad. Now, you and I, we get it. We understand the sarcasm, but for a computer, man, that's a tough one. Is it positive because of the word hilariously, or is it negative because of the word bad? This kind of ambiguity, it's everywhere.
And here's the root of the problem. Our computers, our traditional systems, they think in black and white. It's all binary, ones and zeros, true or false. But our world, our reality is just not like that. It's messy, it's full of nuance, contradictions, and just plain old uncertainty.
So that's the big challenge, isn't it? How do we get these super logical binary machines to make sense of a world that's so uncertain? The answer, it turns out, is to completely rethink the language of logic that they speak.
Okay, so to really get this, let's do a quick history lesson. And this isn't just about computers, by the way. This is about how we, as humans, have tried to classify and make sense of reality for a long, long time.
So, way back, we started with something called a classical or crisp set. The rules were super simple. You're either in the box or you're out of the box. There's no in between. Think of a light switch. It's either on or it's off. End of story.
But then, in 1965, this guy, Lofty Zeta, comes along and introduces the fuzzy set. And honestly, this was a total game changer. All of a sudden, something could partially belong. Someone could be, say, 80% tall. It's not a light switch anymore. It's a dimmer switch. You can have all these different levels of brightness.
So you can see the journey here, right? We went from these rigid, crisp boxes to the much more flexible, nuanced world of fuzzy logic. A huge leap forward. But even with the dimmer switch, there was still something missing, a big piece of the puzzle.
I mean, think about it. A light switch is either on or off. A dimmer switch gives you degrees of onness. But what about a power outage? A power outage isn't 0% on. The whole system is down. The question of on or off is suddenly irrelevant. It's a state of pure, total uncertainty. So, what do you do with that?
And this is where our new toolkit comes in. This is where a whole new way of thinking enters the picture, designed from the ground up to deal with exactly this kind of ambiguity.
And the whole idea behind it, which comes from the creators Salama and Smarandache, is based on a really simple but deep observation. The world is full of this indeterminacy. It's messy. So why would we use tools that pretend it's neat and tidy?
Okay, and this is the big breakthrough, the Neutrosophic crisp set. It does something brilliant. It adds a third official category. So you have truth, you have falsity, and now you have indetermination. For the very first time, the answer I don't know, or maybe, or hey, this is just contradictory, that becomes a real, formal, usable piece of data.
The easiest way to think about this is with 3 buckets. Before, we had 2, a true bucket and a false bucket. And we try to shove everything into one or the other. But now we have a third one, the indeterminate bucket. So that hilariously bad review from the beginning, we don't have to force it. It goes straight into the maybe bucket, where it belongs. It doesn't mess up our other data.
And this seems like a small change, but let me tell you, it's incredibly powerful. By giving uncertainty its own home, we can build systems that make way smarter decisions. They act on what they know for sure, and they are fully aware of what they don't know. So let's see what this looks like in the real world.
All right, let's look at how this all comes together to solve some really tricky real-world problems.
Okay, first up, smarter mobile security. Think about mobile ad hoc networks, or MANETs. These are networks that pop up on the fly. Think rescue teams in a disaster area or cars talking to each other on the highway. There's no central router, it's just chaos.
And the huge problem is that they're always changing. Devices are constantly joining and leaving. The network shape is always shifting, which means the security risk is all over the place. So if you use one static security level, it's just never right. It's either way too weak when things get dangerous, or it's way too slow and clunky when things are safe.
So what do? Well, you build an adaptive security model using this exact logic. The system looks at all these changing factors, like how many devices are nearby or how often the security keys are changing, and it doesn't try to force them into a safe or unsafe box. It weighs them all, including the level of uncertainty, to make a decision.
And the results are just wow. Take a look. The research shows a standard method on the left with a pretty low security level. But on the right, that's a system using this Neutrosophic logic. The security level is way, way higher.
And it's more stable. Why? Because the system is actually using the uncertainty to its advantage instead of just ignoring it.
Okay, another great example is in e-learning systems. You got a platform with tons of students on it. How do you actually know if they're learning the material or if they're just, socializing?
I mean, think about it. A student likes another student's comment. What does that like actually mean? Does it mean I agree? Does it mean I understand this concept now? Or does it just mean, hey, you're my friend? It's a perfect example of indeterminacy. So by using these Neutrosophic sets, the platform can analyze all this fuzzy social data and get a much deeper picture of what's really going on.
So, here's the big takeaway from all this. It turns out that by formally admitting what we don't know, we can build systems that are way, way smarter. Uncertainty isn't a bug we need to fix anymore. It's a feature. It's a valuable piece of information all on its own.
And that leaves us with a really big question. What other problems could we solve if our technology could finally honestly say, I'm not sure, and then actually use that uncertainty to make a better decision? This isn't just a small update. It's a whole new frontier for AI and data science, letting our machines finally navigate the messy, ambiguous, and beautiful complexity of the real world.